Hi, I'm Charles, and welcome to part 18 of the OpenSCAD video series. In this part, we're going to be talking about the intersection for operator and the hull operator. So to get started, we're going to talk about the intersection for operator and what it's for and why you might need it. So let's just pick a general case. If we know what intersection is to begin with, let's take a cube. And a sphere. I made that a little bit too big. Oops. There we go. I think I meant to change the diameter. The diameter is equal to 7 or 6. That's probably good. Okay, I'm done now, I promise. This we can find an intersection of, as we know. And we've taken the intersection. Now, if we wanted to take a more complicated intersection with more pieces, we could add in more pieces. Say we wanted to rotate the cube. So we could do that. Maybe when we want to do the same thing again. And so on and so forth. But if we tried to implement a for loop, so let's just get rid of the cubes altogether. Sorry, I'm not being very vocal, but essentially what we're doing here is we're going to rotate a cube around and take the intersection of that with the sphere. So this might not be what we were looking for to begin with. As we know before, we had a different shape when we did this. If we just take this outside, we definitely know that we had a different shape. But for a second, let's look at what shape we get here. So we get this shape, and if we actually intersected all of these, what it looked like, we should get something closer to a cylinder. But if we take our sphere, well, it actually is giving us more or less what it should be giving. But essentially, the point I'm trying to make is that maybe I can increase this so that it's more prominent. So yeah, if we did this, and I'll take this back, put this back in. Oh, made a mess of everything so far. That's probably not what we might have been going for. We're going for more of a cylinder, although this is an interesting shape. We can, it doesn't feel quite right. So, essentially, the intersection for operator just gives us our for loop, except it essentially creates the objects and does the intersection operator on them, instead of this is essentially one object and then intersecting that with a sphere. So let's do our intersection for operator, and this is the object that we get now, which is quite different, I would say. So let's look at the object that we get from intersection 4. Maybe I won't get rid of it, I'll just copy it. Make life easy. So this is, we essentially get a cylinder, and maybe if we wanted it finer, say 30, and we start to essentially get a cylinder. And that's kind of how it works when you do it with cubes. If you were to make it a little bit more complicated, you get a different object. But essentially, what the intersection for operator is for is generating a bunch of objects and then taking their intersection, as opposed to generating a bunch of objects and then treating that as one object and then taking an intersection of this object that you've created with another object. If that makes any sense at all. So let me give another example. So this is in the documentation, I believe, but what we can do, we can take a sphere, let's give the radius 10 and the FN value 100. Okay, we'll translate it half of its radius out. And now we're going to rotate it around the center. And, of course, we'll add in the for loop. Start with 10 objects. Maybe I'll even add in a variable. S for spheres. So now we have a bunch of spheres rotated around. I can do this so it's slightly transparent so we can kind of see what's going on. It's a little strange. I think that has to do with the order in which they're created, but we can kind of see what's going on. We know there's an overlapping section somewhere here in the middle where all of them overlap. Now, if we were to just do an intersection on all of these, nothing happens. The piece intersects with itself everywhere, so you just stay with the same object. So if we want this piece that's somewhere in the middle that all of them intersect over, we have to use the intersection for operator. Luckily that's relatively easy. Intersection underscore for, just treat it as a normal for loop, and we get this interesting shape in the middle. It seems to be a little bit computationally intensive, so the computer's not going very fast. But this is essentially what it's useful for. Let's see, we can up it to 20. Yep. And it smooths out, and you can hear my computer speeding up. Maybe I'll take this back down to 5. Yep, that looks fairly interesting. Okay, so that's mostly it for the intersection 4 operator. Got off to a bit of a slow start, but hopefully that made sense. So next we're going to move on to the hull operator, and this is one of my favorite operators in OpenSCAD. So, let's say you have, we'll take 2 spheres. What the hull operator essentially does is it joins 2 objects. For lack of a better statement or word, that's what it does. It fills the space in between them. I'm going to give some examples now. So let's see, I translate this 100 over 100 in the Z direction. Actually, no, I prefer to have this in the X direction. Put this right in the middle. So we have 2 spheres, and we're going to hull them using the hull operator. As you can see, they've been joined, and they now made a tube or a rounded cylinder. And hull is not just limited to spheres or cubes. You can do it with whatever objects you create. So, and you can also do it in 2D, which is really fantastic. So let's take a cube and hull it with a sphere. So you get this interesting shape. You can see that it kind of transforms from a cube into a sphere. You can do it with other cubes as well. And any manner of shapes. Maybe you have an interesting rotation on your cube as well. So you can see you get an interesting shapes, and the possibilities with this are vast. It's really a good operator to use in OpenSCAD, and I'm going to be going over a technique that you can use using the hull operator in the next video. So this is really just an introduction. So yeah, I'm going to do an animation just to kind of illustrate how this, in case it's not already clear, this should make it relatively obvious what the hull operator does. So maybe I will just use this cube. And I'm going to rotate it around the y-axis. I think negative 360. Maybe that's a bit fast. So we can see what's happening. The objects are being joined. The space between them is being filled in. Now, it's important to note that if you had any holes in your object, or they were caved in or concave at all, they would be filled in by the hull operator. So let's say to begin with, maybe we have an X. Let's just look back at our cube here. See what happens, we get a plus. And now if we bring back the hull, we should see this get filled in. And we do. So you can see that any empty space, just remove the hull operator, empty space between two outer points, here and here, all this empty space gets filled in. Like that. It could even be, even if we didn't have this part, and just hulled the two cubes, that happens too. Even if they were unioned to begin with, it still happens. So when you hull things, you lose any space that there was in between 2 points. A lot of the time you retain the shape, but sometimes if it's like this, if there are holes or other things, then you lose some of the attributes of your shape. So I'll continue with the animation. Yeah, and that's essentially what the hull operator does. Very useful. Definitely fun to play with as well. And really cool. So that's everything for this part, as far as I can think. So thank you for watching, and hopefully I'll see you in the next one.